Hello friends, welcome to our YouTube channel Ask Concept Builder. I am Deepti and today I will discuss part 2 of our machine learning series in which I will discuss about the types of machine learning techniques. So basically we have four types of machine learning techniques and those are supervised learning, unsupervised learning, semi-supervised learning and reinforcement learning. So we'll discuss each of these learning techniques in detail in the further video. So first one is supervised learning. So supervised learning, with the name only, we can understand that this learning is supervised. That is, some supervision is there in the learning. So here we train our machine using the labeled data and we have prior knowledge of our output values. So these two are the important points in the supervised learning, that our data is labeled and we have prior knowledge of our output values. That is, number of classes are known here. And basically we have to find some mapping between our input and output function in the supervised learning. This all we will discuss in details in our further videos, these mapping functions and all what will come in the this learning. So first here what we will see is how to train our machine. So this I will take with a simple example. With the example you will learn all the small things. So I have taken here a data set. So what is my data set? Here is a collection of fruits. Okay, and this fruits consist of three types of fruits only: apple, banana and cherry. So my number of classes are known here, that I have three types of classes: apple, banana or cherry. So our output value will lie only in these three values only, that is, our fruit can either be apple, banana or cherry. Okay, so how I will train my machine here? So see, if this is my machine, so I will train my machine using the training data set. This is our training data set. Now my training data set comprises of three types of fruits, but what we have in supervised learning, that our data is labeled. So all the collection of fruits which I am passing to the machine, it is labeled. So all the fruits which are apple will be marked as apple, which are bananas will be marked as bananas, whichever are cherry will be marked as cherry. So we have all the collection of labeled data set and this we will pass to our machine. Okay, now what our machine will understand through this, that it will find certain features in these three types of fruits. Okay, so first what it will see, that it has two different types of fruits. One is red in color and other one is yellow in color. Okay, so it, now what it will understand is that in red only it has two types of fruits. One is smaller in size and one is bigger in size. Both are round, but one is smaller and one is bigger in size. And yellow, it has only one type of fruit. Okay, so all the fruits which are bigger in size and red in color are marked as apple, and all the fruits which are smaller in size are marked as cherry, and all the fruits which are cylindrical in shape and as yellow in color are marked as banana. So our machine will learn through our data set that these are the different types of apple marked. Now we will keep on passing this training data set to our machine. Now, after a certain time, we will check that either our machine is trained completely or not. So, we will pass one validation data set to our machine now. So, this validation data set consists of the data, but this is our unlabeled data. We have not marked apple, bananas or cherry to our this type of fruits. We will simply pass some fruits to our machine. So, this is called validation data set. Now, if our machine is able to identify all the fruits correctly, that means our machine is trained completely and our model is ready now to predict further in future these type of fruits. But if our machine is not able to identify the fruits completely, again we will train our machine with the more data. So in this way, this process keeps on going until we get a completely trained model. Okay, so this will keep on repeating. Finally, when we will get a completely trained model, so our model is ready now, and now we will pass some test data set to it, which is completely different from this training and validations data set. Is a new data set of, but it will consist of only these three types of fruits: apple, banana, and cherry only. So now our model can be able to identify these type of fruits. Okay, so what was there in our unsupervised learning? We were having labeled data set, and we were knowing the output values that it can be either of apple, bananas, or cherry. So these are the two important points in supervised learning. Okay, then what is the third important thing in supervised learning is that accuracy. So what is the accuracy of a machine? The machine which we have trained. Now what is the accuracy of this machine? Okay. So here we can see is that all the data which we are passing to the machine is labeled only. So we are giving a proper supervision to our machine. Okay. So mostly our accuracy of our supervised learning model is mostly 100% or 90 to 100%, because it is doing its work only under supervision only. So this is the advantage, or we can say good point of supervised learning is, or why we use supervised learning is to get the good accuracy. To get the good accuracy, we can use supervised learning. Okay, but this I've already discussed. Okay, what are the types of problems supervised learning can solve? So this was our supervised learning. Now what problem supervised learn can solve is classification and regression problems. Okay, so what is now classification and regression? In classification, we have discrete values. Like in our previous example, we have discrete values that either it is apple, banana, or cherry. So our output can be either of these three only. So we have discrete values. Or like if we have to detect that our mail is spam or not, so yes or no, it is spam mail or not mail, so yes or no. So these are also discrete values. So these type of problems comes under classification, in which our output values are some classes which are discrete values. Okay, but and then comes the regression. In regression, our output value is always some integer value. Okay, some value, and we don't know what this value can be. It can be any value, but it is in the form of integer value. Example, price of house. Okay, so like if you have to predict the price of house, so what all the features you can have, that is location of house, or the size of house, that how many bedrooms or bathrooms it has. So based on all those features, we will have some certain price of our house. So that is called regression. Here you can see, this is classification, classifying differently, and regression is our continuous value, some integer value we will get in our regression. Okay, so these are the two types of problem which our supervised learning can solve. Now the algorithms which supervised learning uses are linear regression, logistic regression, SVM, decision trees. Okay, so this linear regression we will use for regression technique. Logistic regression we will use for classification problem. SVM also we use for classification problem. So there are many more algorithms for supervised learning, which we will discuss in our further videos, each and every algorithm. Okay, so we have these type of algorithms. Then what are the challenges in our supervised learning? So the basic challenge we have in our supervised learning is that we have to label the data. But if our data is too big, then it is very difficult to label that much data, because labeling the data is basically the manual thing, because we have not get any accurate algorithm by which we can label the data. So this thing is mostly manually, and so it is a very time taking process. So for big data, supervised learning is not a good learning technique. Okay, so this was all about supervised learning. Now we will move to unsupervised learning. So what is unsupervised learning? Now from the name only you can see unsupervised, that is no supervision is here in learning. Okay, so we are training our machine here using unlabeled data. We does not have any label to our data. So here what will happen, that machine will itself extract some features or some pattern from our data, and then it will group the things, or it will understand the things. Okay, so we can say that it works well to discover new patterns in a data. We are not specifying anything here. The machine will itself learn from the data here. Okay, so classes are not known here. Okay, so this I will tell with the previous example only. Now in the example, but the data set I was having was a collection of fruits. Okay, now here also I am having a collection of fruits, but I don't know. In that I was knowing that it consists of only three types of food, either apple, banana or cherry. Okay, so number of classes were known there. We know that what our output values can be, it can be either of apple, banana or cherry. But here we don't have any prior knowledge of our output values. We have simply the collection of fruits, and we don't even know that which types of fruits are included in this data set. Okay, now this data set only we are passing to our machine, simply this data set. Okay, now what will happen, now our machine has to observe some pattern in this data set to distinguish this data set. Okay, now what our machine can do is, it can see here that there are, on the basis of color, it can differentiate that it can see two types of color, one is red and one is yellow. Okay, so it will make the clusters of two different clusters based on their color. Okay, one is yellow and one is red. Okay, now again what it can observe the pattern here, that in red only it can see some smaller size of fruits and some fruits of larger size. Okay, then again from this cluster it can again form the two cluster based on their size. First cluster was based on red and yellow. Now again when it sees to red, it can form two types of cluster here, one is smaller in size, one is red in size, and the third cluster it is of yellow in size. So based on the features or the patterns what it observe here, the machine has itself formed the three groups based on their features. Okay, now it does not know that what is this, it is apple or banana or cherry, because we have not labeled the data, so machine also don't know. But only it has simply formed the three clusters, three different clusters. Okay, so machine also does not know. So here you can see here these type of clusters machine will form. Okay, in the diagram you can see here based on the features. Okay, now here we can say, because we know, so we can say that this can be bananas, or this can be apple, or this can be cherry. Okay, based on the feature it has itself marked three clusters. So classes are not known here. Okay, now what are the types of problem which unsupervised learning can solve? So unsupervised learning can solve the problem of clustering. So clustering, as you have already seen in the example, it forms the three types of clusters for apple, bananas and cherry. So it solve the problem of clustering. So it is a grouping of same feature. According to the same feature, it has made the cluster. And the types of algorithm which we can use for clustering are k-means algorithm, and many more algorithms are there. Now the second problem which it can solve is association problem. Association I have already discussed that in the previous lecture, that how it is some relation between things. Okay, so for this we can use the a priori algo here. These all algos I will discuss in further videos in detail. Okay, so this was our unsupervised learning, where we does not have any labeled data, only our machine has observed some patterns in our data, and according to that it has made some groups or clusters. Fine. Then comes our third type of learning, that is semi-supervised learning. So semi-supervised means it is only half supervised. Half supervised means it is our in this we train our machine with small amount of labeled data and large amount of unlabeled data. So it is in this data is a mixture of labeled and unlabeled data, with a small amount of labeled data and large amount of unlabeled data. So it is the shortcoming which we are having in supervised learning is that if we are having a huge amount of data, then we are not able to, then it is very difficult to label the complete data. So in a semi supervised learning we will label only small amount of data and large amount of unlabeled data we are having. Now what will happen in a semi supervised learning, the labeled data, with the labeled data the rest of unlabeled data will be labeled by our machine itself. Okay, so This is our semi-supervised learning. So it is used in many applications like speech analysis, web content analysis. All we will see further in detail. So this was our third learning technique. Now the fourth one is our reinforcement learning technique. So what is our reinforcement learning technique? It is similar to how humans learn. Okay, so this technique is a little complex technique because it does not have any label data with it. It has to learn through rewards. Okay, so this I will discuss with a simple example. Like if my friends are playing some game and I went in the middle of the game and asked them that I also want to play this game. So please tell me the rules of the game. But no one is ready to tell me the rules of the game. So now what I will do is I will simply sit here and observe all of them playing. That with which move they are getting some points and with which move they are getting the penalties. So by observing for certain time, I will get to know that what are the moves which are giving me rewards and what are the moves which are giving the penalties. Okay, so I am learning by trial and error method by observing. Okay, so this is the basic thing in reinforcement learning also, that like this agent, I am this agent, I am doing certain action, that making some particular move while playing the game, and if that move is correct, I am getting certain reward, and if that move is not correct, I am getting some penalties. So I will learn in a certain time. So this is all about reinforcement learning. This happens in the reinforcement learning. Now, games are very popular in reinforcement learning search. Many games are built on the basis of this reinforcement learning search. So this was the reinforcement learning. Now, I will give you the overview of all the learning techniques which we have learned. So first one was supervised learning, with which the name only we were knowing that this is under some supervision, under some instructions. Okay, so in this the important thing was we have the label data and we have prior knowledge of our outcome. This was our supervised learning. Okay, then was our unsupervised learning, in which we were not having any label data, neither we were having any prior knowledge of our output values. Our machine only will have to learn here through the data. It have to observe the patterns and it have to make the final result by forming some clusters. Okay, so this was our unsupervised learning. Then the third one was our semi-supervised learning, which was the combination of supervised and unsupervised learning, in which we were having some labeled data and a large amount of unlabeled data. Then fourth one was our reinforcement learning, in which we were learning through reward system. We are not having any label data, but in our environment, how we are interacting, what actions we are making, what actions are giving us rewards, what actions are giving us penalties. By those methods we are learning in the reinforcement learning. So these were basically the four types of learning techniques of machine learning. Now, in the further videos, I will discuss about each of the algorithms used in these four types of learning, like logistic regression, SVM, linear regression, decision tree. All the algorithm I will take one by one in further detail. In this video, if you've had any doubts, you can comment on our comment section. Okay, thank you.